Now we go to fundamental problem 619, right? So you have two members. One is ABC, right, and one is DC. And at point A you have a pin support. At point B you have a smooth support, right? This is not pin, this is smooth support. And at D you have a pin support, right? And okay, at C you have the pack, right? Smooth pack. And then between D and C you have 600 Newton load applied, okay, normal to it, right? And this DC is 45 degrees from the horizontal axis, right? Is 0.5, and then you have some other which is 2 and 2 meter, 2 meter, alright? So the question asks you to find what are the reactions, the components of reaction, okay? Components of reactions at A and B. Okay, so A and B. So basically what does mean by this is if you draw A and ABC, right? A, B, C. So you have to find what is this AX and Y, right? The components of A, which is and Y. And then component of B is just BY, isn't it? Because it is a smooth pin. Smooth contact, surface contact. Right? And then of course this is not enough, you need to find what is the one here. I mean I'm going to show later on, right? Because basically you need to have this reaction, right? Okay, so to start this, actually when you do this, basically you start with something that you have the applied load, right? The load is applied at this DC in this case. So you need to find, to try to find this reaction first. So you do the free body diagram of DC, CD, right? So here you have 600 Newton load in the middle, right? And there is an angle of 45 here. Okay. And then at D, because this is a pin, you have a dx and dy, while at C you have something. That something actually, if you understand, you can do again, you can do long way, or actually you can do very simple way. Now if you realize that actually this DC is actually a 3-force member, not 2-force, 3-force member, then actually it will be very simple, right? How do I know that this is a 3-force member? Basically because this 600 Newton load, you know that here you have another load, right? Of course, if you resolve, you have dx and dy, but you know there is a reaction, right? And at C, actually this reaction at C will be this, which is, let's say, NC, right? Normal to it. How do I know that it's normal to it? Which means it's parallel with 600 Newton, it just goes opposing the 600 Newton direction. How do I know that? 600 Newton is a normal load, right? While NC is the reaction due to this pad, right? Smooth pad. So it will be normal, isn't it? We have seen this in chapter 5 for the types of supports. So the third one here, although you can resolve into dx and dy for the pin, but we know actually this one is simply D. Alright? Right? Which means that NC and okay, FD, let's put it with FD, right? So now DC member is a 3-force member. In this, of course, it is 3-force member. It's just, if you know that this is 3-force member, it will be very, very easy to solve, right? The question doesn't ask you to find what is the FD, but actually will be the same as NC because it's symmetrical about this axis, and actually if you do moment, then we'll get the same thing. Okay, now we'll solve NC. How do we do that? You can do moment, right? Or you can do Fy. In this case, this is Y, right? Y prime. So here I want to do this. I want to do moment about point D equals to 0. So I have NC times 3, right? minus 600 times 1.5 equals to 0. FD has no moment about its own point, right? So NC is actually 300 Newton. And of course, your FD will be 300 as well, right? Okay, now I have NC from this DC member, so I can put it in ABC, right? And then find the reactions, these three reactions. NC is not the answer, okay? The final answer. The question asks you to find AX, AY, and BY. So now we draw the free body diagram of ABC, right? The horizontal member. So NC will go this way, right? Which is 300 Newton. How much is the angle? 45. Right? Check that. 45. Right? And then you have what else? NC is from the back. Okay. At B you have the roller. Not roller. The smooth contact, which is BY, isn't it? And then at A you have AX and AY. Right? Now you can solve this. You can find AX, AY, and BY. Oh, my bad. I made a mistake. There's another one here which is 800 meter. There is a couple moment of 800 Newton meter. But in this case, doesn't matter. I mean for this DC, it has no effect on DC. Okay. But basically here you have 800 Newton meter. Sorry, 800 Newton meter couple moment. Right? Alright, so the first thing that actually we can solve directly is we do fx equals 0, isn't it? Because if you do fx in the x direction, okay, you just have ax and you have this component of 300 Newton, right? So you have ax minus 300 cosine 45 equals to 0. So you can solve ax. Okay, from this you will get your ax as 212.13. Okay, this is your first result, right? And the second one, okay, you can do moment about point B, right, to get your AY. Understand that? If you do that, you will eliminate UY in the equation. So you do moment about point B, alright, assuming for instance clockwise is positive. So you do that one, you have AY times this distance, which is 2, right? And then plus 800 Newton, right? Clockwise plus, and what else? You don't have this, of course. So you have this component minus 300 sine 45, right? Times the distance, which is 2, equals to 0. Right? So you solve this. What is the direction of the number? Okay, right over there. Okay, so you solve this, you will get your AY equals to 612. Right, so you got your AX and AY. Actually, if you do this, you will get AY equals to minus 612. Okay? And then, now you know that actually your AY actually goes the other way around. Right? So you need to explain that. Okay. Finally, we'll find BY. Okay? So to find BY, you do the Fy equals to 0. Okay. What you have AY. Okay, now AY going downwards, 712, right? And then you have plus BY. You still assume BY as going upwards, and you have minus 300 sine 45. You solve this, you get your BY equals to 824.3. Right? And you got positive from here, do you know that your BY is actually positive? Right? Your AY going down. I mean, BY going up, AY going down. right?